You know the path. So if you want a pure air, you do that path for something, then you have to pay for your oxygen. So this is not started now in all very oxygen are there. So this is carbon dioxide reality is there. Energy emissions we know very well. Now population, why we have to upgrade? Population is increasing. 1804, 1 billion. So 2050, 7.5 to 11 billion. So population is increasing. So naturally the demand is also increasing. So what demand? You know the chemistry of medicine, of morphine, toothpaste, toothbrush, knife, medicine. So population we have to think that we can't stop this chemical business. So what to do? They have made the rules. You can see that environmental regulation is there. And that regulation, you can see 1807 long back. This 1807 but we know how our psychology human being understand what we are doing. Because now it's very strict, even though we are not getting that answer. That is why now this incident, Bhopal treasure is very in December, this Bhopal treasure, how many thousand officials, 3,000 per day in this Bhopal gas treasure, and the main cause that is methyl isocyanate is there. Now you see the initial why this thing is happened. Everybody is knowing that methyl isocyanate is less result. So the rules is that we have to get a 2 ton, but they have to get a 50 tons because it's a regular is going on. And that gas they have prepared in a tank covered by cold water. So, cold water, that tank is having, tank they have 50 tons of that methyl isocyanate. So the employees can see what we have to learn from that industry, what we learn from this incident, that there is a leakage between the wall, outer jacket and inner jacket, between there is a wall. And that wall is somebody has studied that now we have to replace it. And airless means the outer water goes inside to the air. That what happened? Explosion. Then the reaction takes place and explosion takes place. And you can see 1984, 3rd December, all hundreds of people died. Now, what is the chemistry? I want to say the chemistry. So, what they are making a RBI. This RBI they are making. What they are using? COCl2, methylamine, so and prepare methyl isocyanate. So that react with alpha and making the very simple chemistry is there, and they are making lots of money. But what happens? This methyl isocyanate, they are cooking for regularly they are using, continuously they are using. The rules is only 5 tons and I will use 15 tons in the tank. And that explosion takes place at the incident time. Now we see the chemistry. What is green chemistry? So here same thing is that. Alpha and tau is that. Alpha and tau is that. COCl2 is that. Right? React with methylamine and so here in this chemistry, there is no methyl isocyanate. Here it takes methyl isocyanate. So using methyl isocyanate, they are using initial one. Here no methyl isocyanate. So what green chemistry? Green chemistry, green chemistry, your chemistry, because you know very well, whatever the research and development, first in the laboratory, then I know, then on the last. So here in the after taking this incident, so because of this incident, third chemist applied their mind. What I mean to say is that instead of this, we know that in the reaction, the toxic material we are not do this. So it's a chemistry. So chemistry student, they have to apply that go to R&D that gives the project. So as a teacher, we should learn, we should learn that and we maintain the reaction and we can find out new things in your laboratory. That in that case, you should know that you should not use a toxic material and that reaction should not develop the new toxic waste. So that is the idea of the green chemistry. So this is the reaction. You will get all this. Your consume is that. So that is also toxic. Then later on, it also replaced by distractors and tablets. So who has given this idea? This is the Professor Sation and Professor Hnsb. In 1990, first time I heard this, first time in the India, 1991, that green chemistry conference was arranged in Delhi University. And I like this idea because now a professor can also teach. Say, professor, what we are doing, whatever in the syllabus that we have teaching. But what is the important part? That is the reaction. We should also force them that this is the toxic material or this type of reaction create a toxic waste or all this. So then when you go for laboratory research, you should not to give this idea. So Professor Warner, he had done a lot of after that I started my work on this. Sulfation, nitration, oxidation, when we have nitration, we are using acid, nitric acid. We know when we carry out sulfation, we are using sodium, that is concentrate, sulfuric acid. So sulfuric acid is 100%. And 20% sodium is more 20% stronger, right? 100% sulfuric acid, you have to pass more 20% of acetic acid. That relation is known as 20% sodium. So all these geometric red flag also here, all reagent, all these process, what we are doing, what we are teaching, that create a waste, toxic waste also, and during the reaction also, toxic gas and all these happen. So what to do? So you can see this is a very chloroglycerol that is highly used in medicine. So in the dimethylpolyethylene oxidation is that so methyl group oxidize and makes a carboxyl group, and then reduction is there and HCl, and then hydrochloride makes hydrogen and chloroglycerol. But you see, from PNP to this, 14 years, 14 years solid waste. So, what if you want to make a 1 kg of this protein, all these reagents, and you are making age. So that is not the so that waste also create a lot of that waste utilized for one purpose, good purpose. Other waste they create a lot of other problems. So here we can see how many waste generally is we can see to attempt to say the that how much that is 2,282. So the factory is very waste short of. So this process now industry will not utilize it and the R&D also if you have set up this type of process and they say no, this is not useful for the because there's a lot of problem arising when you have to make any process. So you should consider all these and if you know because in college we are that where principles of chemistry we are teaching. But what is behind it that we should force them and that is very important. The student also the industry also. So there are so many this type of processes are there. Yet another very important that is a product that is ibuprofen. It's called ibuprofen. Ibuprofen, you will be surprised that as a painkiller, how many tons of ibuprofen they are prepared. So, a chemistry should know that a 70% of medicine having an iodine center, iodine center is there, you know. So, in the medicine, you will find that if active ingredients are there, that active ingredient there should be a thyroid center. But for so many years, nobody is knowing that the same medicine, one utilized giving a good result, and the same medicine utilized by another having a side effect. So why is side effect? Okay, nobody has idea. So then scientist has idea of that. It's a thyroid center. That is a isomers. So isomers are two isomers that two isomers that create a acidic mixture, and in that one isomer gives a side effect, one isomer active, one is. So now we have to separate that isomer. So, so we have to separate it that. So here you can see this is one drug. Example, this drug is sedative effect. Drug is very useful for a lady during the pregnancy giving. And here, within the 3 or 4 years, 5 years, they have withdrawn that drug because they are finding out taking these drugs, you can see the birth defect, like absence of limbs, this thing is happen when they are using these drugs. So how many 5,000 to 7,000 young child infected with this birth defect? So nobody is knowing that one no problem with AIDS, but other type problem. So the finding of this thing then they resolution technique is there. So racemic product they are using, and with that one isomer R and S, you know, one R is active, another S having a side effect. So then every chiral compound, active drug having a chiral compound, many drugs. So wherever the chiral factor, they resolve it, they separate it out, and then they check division. So here you can see all these halonomine. So and as you can see, S configuration. This S configuration transformation effect is there, and R having a sedative effect. Same compound, but the position is different, configuration is different. That is why they give. Similarly, there is NMI. One S is a anesthetic effect, R is a reduced. Similarly, pyroxenamide also, and the control acid and declining acid. So this type of lot of examples, but nobody is knowing that before 50 years, nobody is knowing, and some scientists like you, they utilize the chemistry knowledge. So my point is that chemistry is so important. So this is the things you will get all this. Now this is the hypophase. You can say 28 to 35 million tons of this hypophase every year they are here. But what is the main drawback of this? Here you can see 37 to 46 million pound waste is generated. Ibuprofen is used as a painkiller, but the waste that creates a lot of the cancer and all these things. And then how much? Double than that, 46 billion. So that waste creates a lot of problem. So it is not the greener technique, but this is not the greener crochet. So they have changed the technique. Initially, they boost. They have prepared this boost company. But how much waste, aluminum, chloride, sodium, salt, and all this, and the economy. Then another company, PSC, research and development is going on. Of course, patent is there, but change the technique, change the catalyst. They have used the catalyst within a 3 state, not 3 state, and 77 atom. And now the latest one, that is a nanoparticles, nanocatalyst, all this that create a better than this PSC. So my point is that have to apply this on a lot of opportunities. That is why I say a lot of opportunities in the chemical industry and that, because they are eating billions of rupees. Why they will use? They are getting it. That is why new things, new ideas, new knowledge. That new knowledge, nothing is new. Chemistry say, but just apply to mind that whether it is useful for society, useful in that sense, late air pollution, late water pollution, late solid waste pollution. So all nano material they have used for this. And you know, ibuprofen widely used for adult back pain, period pain, mental pain, neurology, all these pain, this, and that is why the tons of this ibuprofen are. Now the other for reduction one here we can see paracetamol also say paracetamol what we use it using SNSCL and making and then making a simple chemistry is there. But acetylation, acetic acid, and then reduction SNSCL and create a lot of problems. So this is not the green chemistry. Now the green chemistry, same product, hydroxy acid. Simple reaction, ammonia and making this oxime and that converting this parahydroxide parahydroxide. So here no waste is generated and no toxic material used. Now here the another part. What we are doing generally. So here you can see this new technique. So in this technique, iron they have used a iron, water, and carbon dioxide. Carbon dioxide, when you use carbon dioxide with a reaction, and when you go for a last stage, then you will get a credit. Because whatever the carbon dioxide that we are capturing, that they kept in a cylinder, and that they are using, so you will get a credit also, carbon credit, and that uses solvent also. And this used for a reduction, NO2 convert into NH. There is no HCl. My point is that avoiding acid and thereby alkali. What happens when we carry out a reduction? So iron and HCl we are using. And then NO2 is converted into NH. HCl why we are using? So whatever the amine take, so as such, it's not followed. So when you make hydrochloride of this amine, it, but when it's soluble, we want a product for that. What we are adding? We are adding caustic, NaOH we are adding. So we will get this amine. So acid we are using, and then alkali, folic acid as well as so, so both have a in the effluent more acids are there in the effluent and alkali is also there. So that waste creates a lot of problems. The waste to neutralize it, we have to be so many things, and industry will not allow it nowadays. So far as policy is concerned. So what so we have to remove the hydrochloric acid and NaOH. So here that is why they have used the iron is there and peroxide that will utilize for other purpose also. But here no acid, no alkali is required. So this is the green chemistry idea of this. Then we know that we are making azotite. Now studying the dye. For this dye preparation, what we are doing, we already primary amine. First, the azotite with NaNO2 and HCl make the azoinium salt, and that azoinium salt coupled with the coupling compound and make it azotite. So here you can see in this process, in common process, the acids are widely used, and that acid, hydrochloric acid, all this, it depends upon what type of amine, aromatic amine or heterocyclic amine you have used. So toxic acids are there, so that create corrosion and that create the acid waste also. So now what to do? Means when you kids today also to make a azodite means NaNO2 HCl is required. Then for coupling, if there is a phenol, then base is required, sodium hydroxide of that. But if you want to remove this, so here you can make this azodite using solid acid, and that's called a boron trichloride. We have three SiO2. So if you use this and make a dye, so no requirement of this acid. So here I will show you that here you see. This is a how this amine, can make nano silicon oxide material, and then this type of coupling compound, azide coupling compound, we are adding so we get say monoazotide. So here no solvent, solvent-free reaction, means no hydrochloric acid, nothing is there. Here, solvent is no hydrogen, no HCl, no hydrogen, so there is no acid. So this is green chemistry. Still, I have asked many industries, they don't know. They said, we have no idea that. So, reason is that we have to teach them this type of phenomena. With this type of, we have to introduce in our syllabus also. Of course, many universities have introduced this green chemistry, but still, only the 12 principles of that. So, friends, there is a one book I have written because so many foreign authors they have wrote these green chemistry books and that cost is very high, more than thousands. But I have prepared that book only 150 rupees, and that is in the syllabus of Odisha University. And this is available with Himalayan publication. What I have told them that I will not take any royalty of that book, but it should be very cheaper than if you go for Xerox of that book, more than 200 rupees, more than. But when you purchase it, 150, every point I have discussed is that thing. So just you go and read it as a novel, then you have a clear idea what is green chemistry, how far it useful to industry. Then another I will show you that also. Ferric hydrogen sulfate, same thing. The other reagents are used for making the azole. Here, the new method that green methods are there for using that eco-friendly and catalyst only ferric hydrogen sulfate. So, is that also how this ferric hydrogen sulfate prepare that method is already there. Cost is very low and no pollution. They keep this chemistry FHH, that is a very hydrogen sulfate. And make a azole that normally whatever that we have that makes it azole. So there are so many this type of methods, but we should apply our chemistry knowledge. Now, bromine particularly important to say that carry out bromine, liquid bromine itself is very corrosive. One drop of liquid bromine that corrodes your corrode. So use the liquid bromine. So what is the alternative? The last because fuse is also very generous. So for that, there are some alternative important investment. I will show you. Eco-friendly bromine. See here, see, bromic acid there, boric acid they have used. This boric acid is there. And in India, so using this bromine water in India, no liquid bromine is there. And carry out this bromine CH3 carbonate CH2. So you can apply for so many others. You can apply for this type bromo. You can also take double bond. You can break down and say like bromo. Here, like bromo is there. Similarly, simple. Para-bromo, this boric acid is here. Para-bromo. So simple method is there. Just you have to apply your chemistry knowledge. You can also utilize using HDF and hydrogen peroxide. You can make a HDF and you can make. So in the industry now they are using all this. All drugs they are making using nitrogen dioxide and carbon is a problem. Here you can see a domination with no solvent. Generally, for domination, what we have used either a chloroform or carbon tetrachloride. But here, there is no liquid bromine. Here, there is no solvent. Bromine is there. But instead of tetrachloride and chloroform, they have used carbon dioxide. So you see, there is a lot of many industries, they are using carbon dioxide. I will show you that slide also. From carbon dioxide, they are making a lot of urea, salicylic acid, lot of chemicals that is on the large scale, not at a laboratory scale or a pilot scale. Is different. Here also they use instead of all chlorine and all, they have used carbon dioxide as a solvent. Super critical carbon dioxide. We know carbon dioxide very carbon dioxide gas is also there, carbon dioxide liquid also there, and carbon dioxide solid is also there. Solid ice. So that depends upon phase group, changing the temperature and pressure. Gas converted into liquid form also, solid form also. Using that, phase, we are taking the solvent. So solvent also we will take enzyme also. And put the carbon dioxide they are using. So here we very interesting sulfur-oxidation on a large scale, that is MCPA, that is metachlorophenoxy benzoic acid. So in industry, pharma industry widely used, and just a change, just they have applied it. Instead of this metachlorophenoxy benzoic acid, so SO2 converted into, here you see it, SO2 into as sulfur-oxidation is called, and for that they have used this metachlorophenoxy benzoic acid. Still they are using, but now they have changed simple technique. Instead of this costly material, they have used sodium hypochlorite for sulfur-oxidation. They have used this sodium hypochlorite and sulfur-oxidation will be. And how much advantage? But industry get benefit, lot of benefit. I will show you that they use a sodium hypochlorite. So and they have used this metachlorophenoxy benzoic acid. So initially metachlorophenoxy benzoic acid was 95 grams, and here you can purchase a gram, and here only 21 grams. Reaction time is 72 hours will take metachlorophenoxy benzoic acid. Sodium hypochlorite 24 hours, and it is 46. Here it is 70. And you can see how many cost of this. $50, 1 kg preparation, $50 are there. Here only $0.5. So how much the cost wise also effective, and how much you can see the sodium hypochlorite is the cheaper one, and you can visualize. Now it for all sulfur oxidation they carry out. So a lot of things are there. We give me the time because I gave me the time. I will consider it. Yes. Okay. Now solvent free. This is a new thing everywhere. Student or teacher say that we have no chemical. What type of research we can have? But everywhere difficulty is there. But chemistry can finding out. Here I will show you the how you can get new materials, new reagent. Is required. Suppose there is different types of amines are there, and that is that ANB. It's not that easy. You have to apply the chemistry knowledge. You will take any material A and B and write it, you will take no. So that is the chemistry of the writing. And it is not in the laboratory only. Large scale preparation industry, they are also using this grinding tech. I will show you so many examples of this. As you see, this is ammonium chloride. They were grinding only one and they perform so simple grinding technique and you can publish this type of paper in New Material. There is a special journal of this grinding. Lot of people will find on internet. So can make a different product. Basically reaction also you can utilize it. And the ferric citrate, yes, of course, catalyst role is very important. Three components, one reaction, lighting, has to use this catalyst, and you will make this type of experience there. So, lot of, I'm not going to give all these are there. Then another type, that is a reaction with water. Generally, teachers what they carry out your reaction in a class, I will water. So your class will be totally free from water. Generally, many reaction is water and the product. You can be perfect results. But there are so many reactions where the water is useless solvent. Because whatever the application and whatever the solvent come out, the pharma industry, lots of millions of tons per day solvent are using and that solvent creates a lot of problem. And so we have to clear the process. Industry, pharma industry, they say that remove the solvent. So there are some reactions. So here you can see removing solvent and the water is a solvent, cheapest also and no air pollution. So here you can see that water always dies under reaction, result reaction, making Michael, alcohol, non phenol, adjoint condensation, hatch, boost, all types of chemical reaction area of using water as a solvent. Now, this is very important for a chemist, student and chemist teachers also. So, this is a professional Victor. You can see both are same face. Before this, Victor that is a polling university professor. He is working on diabetes. You see, and we go to the teachers also. So friends, never made any chemical. When you make hundreds of your cells, body cells, damage. So same thing happened. He is a professor in university working on dioxin. After few years, he coming out that why I have this type of defect in my body? What is wrong? So he told me doctors, hospital, but he that gave even the so after 3 months he found that now I feel good. Means the effect slowly changed. And he's a professor after all. I'm using some angles and that angles, I will get it back. Let us go. Again, he went to his laboratory and then he found what type of angles I'm using. So maximum average he is using his research lab. Then he stopped, remove all this average and return that whatever is effect in my faith so that is why then he declared that who provide both these photos, say to all people, but first we can check it out whether your body will accept or not. But we never go that. So that is why we try to bring you